Hi, I'm Marta Martinez, and within our overview of the requirements and challenges of 5G communications, we will now take a look at what is needed for antennas for user equipment. There are several key issues that had to be dealt with for 5G user equipment. First, that we are not talking anymore about a single kind of mobile devices, but a myriad of forms with different characteristics. For example, the devices that will be needed to access the cloud, wearable devices like, for example, the Google glasses, car-to-car communication devices, industrial environments, etc. For that, we will need multifunctional and reconfigurable terminals that cover the frequencies that go almost from DC up to the gigahertz and beyond. We will also have to integrate a large number of antennas within these small devices and also take into account different aspects like beamforming, pointing address, etc., and increase functionality, for example, for smartphones. As I said before, we also have to integrate all this in very small terminals, like, for example, eyewear, glasses, or watches. Still, we have the same old problem. Where are the antennas? Nowadays, most antennas, or almost all the antennas, are integrated within the devices. But if you take a look at them, it's very difficult to find them. If you just tear down one of your smartphones, you can see inside we have very cramped space. So the space available to include the antennas is very, very limited. And if you put the antenna inside the device, it will be with a strong interaction with all the other components that are inside. And they have to be able to operate in an efficient way without interfering with the functions of the mobile phone or any kind of terminal. So if we want to know where the antennas are, we can either open the devices or maybe take a look inside, looking, for example, at what is provided by the FCC in the US. That gives you an overview of how the different manufacturers can integrate these antennas in their present terminals and maybe give us an idea of how we can proceed for the future. For example, here we can see what happens in the Samsung Galaxy S. You can see here the commercial handset, and here it's the diagram that has been published by FCC. You can see that we have many different antennas that go from the cellular antennas on the bottom of the device, which is a different with respect with the different devices we had in 2 and 3G communications, in which typically the antennas were on the top of the device. But now we don't only have the communication antenna here on the bottom for cellular communications, we also have the Wi-Fi antenna, for example. We also have a WiMAX antenna just for reception, for diversity or for MIMO options. We also have another antenna for WiMAX, this one for transmit and receive. We have the GPS antennas for navigation purposes, and also a secondary antenna for mobile communications, for cellular communications. This one only receive for diversity and MIMO. The same happens if we look at the Galaxy S5. You can see that as we have a new device, the position of the antennas has been changed with respect to the other one, but we find the same main characteristics and the same functionalities. We have, again, the main antenna on the bottom of the device. We have also, for a single band of LTE, which is not covered by the main antenna, a secondary and smaller antenna that is placed here. We also have the wireless LAN antenna on the top. We have a second wireless LAN antenna on the left side of the device, and the GPS antenna, for example, would be here on the corner, etc. And as you see, it's very cramped, and all these antennas couple very strongly between each other. So this is something we have to take into account in the design. If we take a look at the iPhone 5, for example, we see that they have other kinds of antennas, but the placement is very similar. We have the primary cellular antenna is a PIFA antenna on the bottom. We have the GPS antenna, also based on the PIFA contact on the top, and it acts at the same time as a secondary cellular antenna. And we have the Wi-Fi and Bluetooth antenna also on the top of the device. So once we have designed the antennas, we have also the challenge of characterizing them. If we move to 5G communications, we will need also new setups that are device dependent maybe, because we are dealing with different frequency bands and with different forms, shapes, weights and size of the devices. So the typical setups that we are using nowadays may be not enough to characterize the antennas in the future. We also have to deal with the new frequency bands and require new standards to be developed. We also have to cope with different SAR issues that are not considered nowadays. For example, the measurements and the simulation of the specific absorption rate in new frequency bands, for example, in the millimeter wave region. This will also request the development of new human models, the characterization of the human tissues for different frequencies, and high-resolution numerical simulation, which will need also more powerful computers to cope with the finer discretization that will be needed for these applications. Moving to 5G, we will also have to need new technologies and fabrication for the fabrication of the antennas and new materials. For example, we may consider using nanoscale technologies, carbon nanotubes, graphene applications, etc. We will need also greener and more powerful devices. We will need also to increase the lifetime of the batteries, etc., and the computing possibilities of the devices. We have some technologies that are nowadays already in use, for example, 3D printing and laser direct structuring that can be used for implementing the antennas. They are already in use now and can be still used for the future. And with that, we may have more design freedom and moving to the 3D design of the antennas. So, what's in the future? Well, here we have, for example, a concept developed some years ago by the Nokia Research Center in cooperation with the Cambridge Nanoscience Center, in which we could have mobile devices that were flexible and integrated everything in a very small device. It's transparent, it can be conformal, etc. They were planning at the time, some years ago, to release it around 2016. So, is this the future? Or maybe is it already the present? For example, Samsung has already presented a graphene touchscreen that they could implement in the near future, or at least that's what they say. So, thank you for your attention.